Today is Wednesday, and we're going to talk about sex-linked traits. Sex-linked traits is our third non-Mendelian type of inheritance. The first was incomplete dominant. The second was co-dominant. And we are on to sex-linked traits. So today I wanted to show you this karyotype, and we've looked at these before, but this karyotype is just a simple karyotype. But right here, on the 23rd pair are the chromosomes that are different for boys and girls. So these are called sex chromosomes, and they determine gender. If you are male, then you have XY. It's the Y chromosome that actually turns on the signaling for the cell to have the testosterone and all the genes come through that make the individual male. And then if you are XX, you have a homologous pair. So males, that's a non-homologous pair because they do not code for the same traits. The X and the Y don't. And so if you are a female, then you have XX. And so we are looking at traits that are carried on the X chromosome. And we call those sex-linked traits. Sometimes you'll hear them called X-linked traits because they're linked to the X chromosome. But typically we call them sex-linked traits. There are some Y-linked traits that are linked to the Y. We don't usually talk about them too much, except maybe every once in a while to see how they're passed on through families. But there aren't very many genes on the Y chromosome. And basically it's just passed from father to son, father to son, father to son, like that, you know. And so, so there's not anything too crazy about the inheritance there. So with sex-linked traits, you have to do your Punnett square just a little bit different. It's not unlike incomplete and co-dominant very much. Like there's a lot of things that are the same with it. And so it'll feel pretty familiar. But the difference is that now whenever it didn't matter, like male or female or mom or dad or maternal, paternal chromosomes, now you have to actually like indicate which is which. And so, so we do that by actually putting the XX for the female and the XY for the male. I typically make mine lowercase, not because it's supposed to be lowercase, but because whenever I make a Y like that, sometimes it looks like an X. Like if I'm going really fast, then it's confusing. You can do yours either way. So if you just want to very carefully make it a Y, you can do that, or you can do it lowercase. You might see me do that both ways. Okay, so a couple of traits that are sex-linked. Some of the favorite ones are colorblind. I shouldn't say favorite. This is red-green color blindness. Okay, and this is the part in your Google Meet when I would say something like, raise your hand if you know someone who is colorblind. And in my classroom, usually, about 10 or so kids will raise their hand, maybe more. And then I'll say, leave your hand up if that person is female. Most hands go down. Like maybe one person in every like 3 hours will know a female who is colorblind. And I'll be like, well, why is that? Like, why are there not females that are colorblind? Now, to be fair, there are colorblindnesses that are not red-green, and those are seen equally in males and females. But red-green colorblindness, where you can't differentiate between red and green, they're mostly males, and we're going to talk about why. So red-green colorblindness, first of all, it's recessive. Okay, so there's a little bit of Mendelian tossed in here. So you have a little bit of Mendelian mixed in with a little non-Mendelian. So there is recessive. So we're going to use B's for our allele. So colorblind would be that one, and normal color vision or typical color vision would be the big B. And I use B's for blindness instead of C's because C's are very hard to tell a capital, like a dominant capital from a lowercase. And so I use B's for blind. I just use that instead of the C for color. Okay, so let's say a mother who was heterozygous for color blindness. So she's not colorblind. She can see color. But she carries, please write that word down. I'm not sure if I've said it before. She carries colorblindness. That means whenever you're a carrier, that means that you don't have it, but you could pass it to your offspring. So essentially you're carrying it hidden where nobody knows you have it. So basically what's happening in your eye proteins here for making your rods and your cones that see color in your eye is you have, if you're female and you're a carrier, you have some of the proteins that would be able to help you have color vision. You have some of them that aren't working, but you have enough working that you totally don't notice. Okay, like all of these are working, and so you're fine. Like you're not half colorblind, you're fine. Okay, let's say that she marries a man that sees like typical color. Okay, so a woman who is colorblind marries a man who is not colorblind. No, I'm sorry, I just totally said that wrong. A woman who carries colorblindness, marries a man who is not colorblind. Now, you could be like, is he homozygous? Is he heterozygous? There's nothing here. The Y doesn't get anything because think of the karyotype. X and Y are non-homologous chromosomes. They don't have the same genes, okay? So you are not seeing any B at all here because there's no color blindness or there's no color vision gene on the Y. They don't have the same genes. So don't ever put a letter on a Y if it's an X-linked trait. If it's this X-linked trait, no letter goes on the Y, okay? So then you put them together, and for the first time, it makes a difference if the offspring is a boy or a girl. We aren't going to do ratios with these. The ratios basically get so convoluted that we don't even know which end is up. So we are not going to do ratios with sex-linked traits. So all we're going to look at is our percent chances, okay? What is the chance? There's three things that I could ask you here, okay? So I want you to pay very close attention to the question when you read it. What is the chance that their offspring will be colorblind? Offspring in general. What odds do I have for offspring in general? Something out of 4, because all these are offspring, chances of an offspring, okay? So colorblind? No. Colorblind? No. Colorblind? No. Colorblind? Yes. 1 out of 4, 25%. What are the chances a girl will be colorblind? Oh, I don't have 4 on here anymore. Not 4. I only have 2. No. Okay. What is the chance that a boy will be colorblind? I only have 2. Woo-hoo, colorblind. Males have a higher chance getting it than offspring in general because they only have 1 chromosome that's carrying the gene. Therefore, if they get a chromosome that has the colorblind trait, they don't have another one to cover it up like this girl did. This girl had 2. This one would produce the proteins that would help her eyes to make the right, to have the right structure to see color. This one doesn't. That's the only one he got. He doesn't have that other one. So now his is producing the protein that doesn't see color. That's what he's got. So if they have a little baby boy, a little bouncing baby boy born, 50% chance it's going to be colorblind. If they have a little girl, not a chance at all. Because dad isn't colorblind. So as soon as we knew that dad wasn't colorblind, we knew the girls weren't going to be colorblind because he would give them the only allele he has, that one allele that codes for color vision. And so all of his daughters would have it, and he doesn't have a thing to do with his sons because the sons get the Y from him. And so he doesn't have anything to do with the color vision in his sons. All that comes from mom. And mom has 50-50 chance. Okay? I mean, of giving her offspring. Not for her. She's color vision. Okay? All right, cool. Let's do a practice problem. Okay, so if you have, let's say you have a mom who is a carrier, once again, crossed with a colorblind man. Let's just see what happens then. Now your chances are going to change because now you actually have your male is colorblind. So let's put our letters on our Punnett square. Okay. Now it's the same chance because you had, so now it's offspring. What are the chances the offspring will be colorblind? Is 50. Girl, 50. boy, 50. This one's 2 out of 4. This one's 1 out of 2. 1 out of 2. Okay, remember, these are boys. Those are girls. Unless you put your dad up here and your mom there, and then it'd be like up and down. Okay. All right. So hemophilia, that's a disease where blood doesn't clot very well. And so you like bleed a whole bunch. Like you don't make your blood clotting platelets aren't working very well. And so that's sex-linked trait. There are some other sex-linked traits in some other animals too. And we talk about like male pattern baldness. That's one. That's a sex-linked trait. But we talk about some things like cats and dogs. And so you'll have some practice problems to work for these. Make sure that you'll probably just have a bunch of practice problems to do for all types. Now, we only have one more left, one more type left. And then we've done all of our types of non-Mendelian in this week. So do your practice problems. Let me know if you need any help. Thank you for watching this. Hopefully I'll see you on the Google Meet tomorrow.